Today, we're going to build something truly fundamental, a circuit that can actually remember things. And we're going to do it with one of the most famous chips ever made. Let's jump right in and build a 1-bit memory from scratch. It's a pretty wild question when you stop and think about it, isn't it? We think of memory as, a brain thing. But how can a bunch of lifeless components hold on to a piece of information even after you've taken your finger off the button? Well, that's the puzzle we're about to solve. So the secret sauce here is a concept called bistable. It's just a fancy way of saying the circuit has two and only two happy places. Kind of like a light switch, right? It's either clicked on or it's clicked off. It doesn't just float in the middle. And that stability is exactly what lets it hold a 0 or a 1, the very language of computers.
All right, so how do we actually build a circuit that has this cool bistable property? Let's get our hands dirty and make our own little piece of memory.
And really, when you get right down to it, that's all computer memory is. It's just billions of these tiny little switches, each one holding a single bit of info, an on or an off. What we're making today is one of the essential building blocks for all of it.
To pull this off, we're going to need a little help from a very special friend. It's time to meet the hero of our story.
This little guy is the 555 timer. It's an absolute legend in the electronics world because it's just so darn useful. Now, ironically, we're not actually using it as a timer today. Instead, we're setting it up as a latch. Think of it as a device you can tell to turn on, and it'll just stay on, holding that state until you tell it to turn off. It's going to be the brain of our whole operation.
All right, you know the drill. Every great project starts with getting your parts lined up. Let's take a look at what we're going to need for this build.
And here it is, your mission toolkit. We've got our 555 chip, an LED so we can see what's happening, a few different resistors, our 2 push buttons for commands, a couple of capacitors to keep things stable, and of course, a breadboard and a power supply. It's a pretty simple list, but trust me, we can work some real magic with this. Now, I know an 8-pin chip can look a little intimidating, but here's the good news. We're only using a handful of its pins. This little cheat sheet cuts right through the noise. Pin 1 goes to ground, pin 8 gets power. Pin 2 is our set button, and pin 4 is our reset button. And finally, pin 3 is the output that'll light up our LED. See? That's all there is to it.
Okay, with our components ready and our cheat sheet in hand, it's time to actually build this thing. I'll walk you through it, one connection at a time.
First up, let's give our little brain some juice. Go ahead and gently press the 555 onto the breadboard, making sure that little notch is facing up. Now, connect pin 1 to the ground rail and pin 8 to your positive 5-volt rail. Then, we'll add those 2 capacitors. They act like tiny, super fast batteries that smooth out any ripples in the power supply, keeping our circuit happy and stable. Next, let's hook up our inputs. We'll connect one button from pin 4 to ground. That's our reset. And the other button from pin 2 to ground, that's our set. Now, for each of those pins, we also need to add a 10K resistor that goes up to the positive power rail. These are called pull-up resistors, and they're super important. They basically hold the pin at a high voltage by default. When you press the button, you yank that pin down to low, and that's the signal the 555 is waiting for. And finally, the last piece of the puzzle. Let's connect our output so we can actually see the memory in action. We'll connect our LED from pin 3. The current will flow out of pin 3 through our 220 ohm resistor, which acts like a bodyguard for the LED, and then through the LED itself down to ground. And just like that, our circuit is complete.
And there we have it. The circuit is built. All the theory, the components, the careful connections, it all comes down to this. It's time to power it on and see if we've actually created a circuit that can remember.
Okay, here we go. Let's press the set button. The LED turns on, and when I let go, it stays on. It's working. Our circuit has latched the on state. It's remembering. How cool is that? Now, let's press the reset button. Boom. The LED turns off, and it stays off. We've done it. We have a fully functional bistable memory latch.
Now hold on. If you're building along at home and your LED isn't cooperating, please do not worry. That is a totally normal part of playing with electronics. It happens to everyone. Let's run through a quick checklist and see if we can figure out what's up. First, the classic mistake. Is the little chip facing the right way? Double check that the notch is at the top. Next, make sure your power and ground rails on the breadboard are actually connected to your power supply. Oh, and a big one. If the chip ever feels hot, unplug the power immediately. That's a sure sign of a short circuit. And finally, just take a second to trace the paths for those 10K pull-up resistors and your push buttons. A wire in the wrong hole is usually the culprit.
If your circuit is now working, then seriously, congratulations. You've officially built a physical device that can hold one bit of information. This little latch you just made, it's the great-great-great-grandparent of the billions and billions of memory cells inside the very device you're watching this on right now.
So, that leaves us with one final, exciting thought. You've created a circuit that can remember a command. It can hold a state. But instead of just lighting up an LED, what else could you make it control? A motor? A relay that turns on the lights in your room? A buzzer? The possibilities are literally endless. Now that you can make something remember, what will you make it do?